everyone. I hope you are having a good day. Namaste. I'm Shrut Sanghvi, and today I'll be speaking about quantum cryptography in XT Summit 2020. Let me just share the screen while I set the context. Why should we be talking about quantum cryptography? Quantum cryptography is going to be essential in the upcoming years. Today, I'll be focusing on the need and the simplicity of quantum encryption over its traditional digital encryption counterpart. Apart from that, we'll be taking a deep dive into quantum random number generation as well as quantum key distribution. So, moving on. Why do we need to talk about this? Well, we as a society are very near to quantum supremacy. As each year passes, quantum computers get ever more powerful and are taking over classical computers in very specific applications such as weather predictions. Quantum computers have a definite edge over classical computers, and a lot of companies have claimed quantum supremacy. As we move forward, it will become paramount for all of us to move to quantum encryption, mostly because all current forms of encryption can easily be broken by quantum computer using Shor's algorithm. So, simply put, you want quantum encryption mostly because you don't want people to snoop on you and steal money from your bank account. Let's move to the next important question. Why should I be the one talking about this? Well, I have 0 years of work experience. I have worked on 0 projects and have achieved 0 deliverables. I am a new hire at Publicis Sapient, Shrut Sanghvi. I have bright ideas and a bright future. एंड हिंदी में कहते हैं ना, मैं शून्य पे सवार हूं, मैं बेअदब खुमार हूं. Also, I have a deep-seated interest in cryptography. In my first year, I implemented RSA and spent a lot of time on quantum computing and quantum cryptography in my last year. It was my capstone BTP project. I think I'm qualified to talk about this because I have put in work. So, what is an issue with a lot of current security systems? A lot of security is based on unpredictability. Let's take a very simple case. Everyone knows your phone number. Someone can simply take a look at your credit card and find your credit card number. What makes them truly secure is two-factor authentication via an OTP. What makes an OTP secure? It's secure because it is unpredictable. Now, it's unpredictable, but it still gets generated by a computer. A computer is a pseudo-random number generator. Its results are very difficult to track, but they can surely be tracked. All of us have read in newspaper about a mathematician winning the lottery, people figuring out patterns for slot machines in casinos. Yes, all of these can be done if you are very smart, and a lot of our current security system depends on seed values, which truly need to be random. This creates a catch-22 situation. You need truly random seeds, and you need to change your seeds from a certain time. But it's very difficult to get true random numbers from all your standard random number generators. So what do? So the pseudo-random number generator with a seed value is a deterministic evolution. It's very predictable. Yes, it's very difficult, but very predictable. If you are smart enough and if you have enough computing power, you can do it. What's chaotic evolution? It's very difficult and it cannot be predicted very accurately even by a supercomputer. It's like turbulent flow and it cannot be predicted, but you can make very good educated guesses about what it ought to be like. And if someone is smart enough, they can be in the ballpark and they can get it right. As showed in the last slides, we have people who predicted winning lottery ranges, we have people who predicted OTPs, and a lot of more scams that you have heard of. What makes quantum random number generation truly special? It is inherently unpredictable. The spin of an electron is not determined till you measure it. And it's not because you are measuring it or I am measuring it. It's because it is the nature of the electron. It is a law of nature and cannot be influenced by any external factor. This is what makes it truly unpredictable. It is unpredictable because its nature is to be unpredictable. Moving on, what is entropy management? Let's say you want to go for the chaotic path. Let's say you say, I'm good enough with having lava lamps and classical chaotic RNG. It's true RNG and I will get it right. And so what's the issue with that? Well, for one, it's very difficult to maintain and it's very expensive. You will need hundreds of such lava lamps in a room. And then you will take pictures of these lava lamps. And then you will use some very sophisticated algorithm to convert these blobs of moving liquid into a hash code. It's very difficult to maintain. It's very difficult to check if it's truly random. And furthermore, it's very, very sensitive to external factors like the temperature of the room, the vibrations in the earth, 100 other factors, the density of the liquid. So it's very difficult to maintain. The best thing about quantum RNG, it's readily available. It is easy to understand. It can be checked and modeled easily. The biasing algorithms are simple enough that the person with 0 years of experience can understand it. Well, how does it work? Well, you have a quantum interface material and you have light. Half the time, it lets the light pass through, half the time it reflects it. Get it on two different detectors, and you have a random bit sequence. Or it's more practical applications. The second one, which is these days found in phones, in the Samsung phone, which is available in Korea. How does it work? Well, you have an LED. And if you notice, and if you very carefully measure it, the amount of light coming from an LED deviates around a mean level. The deviations are captured using a CMOS sensor. And the CMOS sensor is configured in such a way that in 1 unit time, one photon falls on one of the sensor cells. Once you have that, you just read the data, you have your random bit sequence, it's your entropy, give it to a hash-based system, and you have your RNG data, and you can always keep checking it because it's very simple. It's like 50-50. So you can, and it's truly entropic and it cannot be affected by anything around it. That is what makes it truly special. Where it is used? Well, we as developers love two things, mobiles and the cloud. Well, it is already available in the Samsung Quantum phone in Korea. Yes, it's a little expensive, but it's available and you can buy it. There are few companies such as ID Quantic and Quintessence Labs. They are already shipping PCI expansion cards which are used in data centers for RNG. They're used for system critical tasks such as setting seeds or very secure transaction and key exchanges. Moving forward, let's go to the key distribution problem. Well, let's say I want to talk with you and there is an eavesdropper, or in the quantum sense, there is Alice who wants to talk to Bob, but there is Eve in between. Well, you need a secure channel. But for a secure channel, you need to give Alice needs to give Bob a secret key. The issue is, whenever Alice gives Bob a secret key, Eves can listen in. So you say, okay, use a previously encrypted channel. Well, the same problem with the previously encrypted. channel. So how it's done today? Well, it's either done by a physical exchange of keys, the use of a courier, or use of a previously encrypted channel, which I explained before is a catch-22 situation. And you cannot get away from this key distribution problem. Well, this is where the true magic of quantum encryption comes in. We have a solution to this problem. So now we have Alice, Bob, and Eve. Eve right now has infinite amounts of computational power. She can listen in on anything. But don't worry, Mr. Bachchan is here to the rescue and he will help us figure out how we can use quantum key distribution. So how does it work? Well, you have a random number generator, you send a lot of bits over the public channel. Over the private channel, you send quantum signals. Bob measures it according to the protocol decided. And the best thing about it is they can just match around 70 bits of their key. And if all of the bits match, well, good, the key is correct. Use the remaining bits as your key. If not, well, what if you have an Eve listening in between? Well, Eve also still needs to measure it. Eve needs the random secret key from the random channel. But as soon as she measures the random secret key, it changes for Bob. And when Bob and Alice compare the first few digits of their keys, they will realize, oh, our keys are not matching. Someone's listening. And if someone's listening, they can just do it all over again. Also, if any of you are interested in mathematics, encryption used by quantum key distribution is a one-time pad. And the one-time pad is the most secure mathematical encryption possible. So, not only does it solve man-in-the-middle attacks, but it also ensures that if there's an eavesdropper, you get a warning. Okay, you will ask me, Shrut, this sounds so awesome. Why are we not using it? Well, it's very expensive. And apart from that, it is very susceptible to DDoS attacks. What are DDoS attacks? Well, just cut the quantum channel. And what's a quantum channel? It's just a piece of fiber optic cable. If you cut that, there is no more quantum key distribution. And routing to other routes is almost impossible because you need the signal to go in one shot from Alice to Bob's. Hence, this is not being used these days. All right, so let's look at the current applications of quantum key distribution. Quantum bank transfers have been carried out since 2004. They are used for very high value transactions, and the first one was carried out in Vienna, Austria. From 2004 to 2007, a 10-node network was continuously run in Massachusetts. It worked for 20 hours a day for 4 years. It performed so well that currently it's out of testing phase and its use is classified with the Department of Defense in the United States. And for secure communication, well, we had the first quantum secure call from China to Austria. It is the first intercontinental quantum video call. With quantum video call, we can do all of our meetings online and we can work from home forever. Doesn't that sound like a wonderful world, people? Moving on, the market opportunity. The current market is pretty small, about 125 million in 2021, mostly defense contracts and a little bit on the consumer side. I believe it will balloon up to 2 billion or 1.5 billion by 2022, mostly because when Samsung comes up with this market leading product, which is more secure than everyone else, well, everyone else has to match them. By 2030, we will have true quantum supremacy and everyone will need it. it will be the encryption industry. And this will be a $40 billion market. Currently, the market has a very few startups and it's very young. Any company, even Publicis Sapient, could go in there and dominate the space for years to come. All right, moving on. I would like to finish my presentation here today. I would like you to invite you to mentor me, to teach me and help me on this quantum computing journey. I'll be moving forward and I will be waiting for you as I look to explore quantum encryption, quantum computing, and its daily use. Thank you, everyone. I hope you had a good day and thank you for listening to my talk. Xiao.